My name is Ekaterina Podlesnaia, and I am doing a PhD in physical chemistry. You're welcome to the Nano Lab of Biophotonics group at IPHT. Here I work on a synthesis of gold nanoparticles in such shapes as spheres, triangles, rods, and even cubes. These are tiny little crystals in sizes of nanometers, which you can't really see with the naked eye, but you can only image them with the electron microscopy methods. My research subject is plasmonic nanoparticles, and they exhibit special optical properties due to the plasmonic resonance on the surface. It's an oscillation of electrons, and if we locate several particles on a fixed distance between each other, we can see the near field enhancement, which can be linked to the main theme of the event this year, which is tension. I am focused on different types of nanoparticles, which can be made of silver or gold or some other noble metals as platinum or whatever other different materials. And depending on the materials we use, we can obtain different colors. But also the color is dependent not only on the material we used, but on the size and shape of the particles. So for example, the yellow is for spherical silver particles, and the orange is when they grow bigger and probably become already nanoprisms, and the blue one is also for the silver nanoprisms but of larger size. We also need to take care of the sensitivity of our nanoparticles. That's why for the longer storage we keep them either in a dark cupboard or we cover them with foil because they are light sensitive, and then we just light it in the device and measure the signal shift to detect if there is something present in our sample or not. Yeah, experimental part is always hard to influence. You only do an assumption and then you give it a try and hope that it worked. But until you measure the final result, even by just looking at what you have done, you can't really be sure if the outcome is worth it, or you have to do it once again or plan an experiment in a different way, for example. I would locate it right in the middle because we have a fundamental base without which we can't do any experiment and predict the result. But on the other hand, there are still things to be done in the lab and be tested. Plus, we also do the application of our nanoparticles on the glass substrates to prepare the chips for sensing. So it's right in between of both. It's a mixture. So as a chemist, I'm more interested in the fundamental part of research, but in my group we do nanobiophotonics, which means a combination of nanoscience with the biochemistry and photonic technologies. We hope to end up with the sensors which can detect pathogens in water, for example, and that's why we are also dependent on many other fields of sciences, such as an instrumental part coming from engineering or some biochemistry advances to get some biosamples to be analyzed, for example. The sensor detects the wavelength shift, which comes from the ultraviolet visible spectrum, and with your eyes you can see it just as a color shift, for example. If not being very accurate, it would be like a shift from red color to the blue. If you have pathogen, if you don't have any, nothing is happening. I can start noticing things which are unusual in a daily routine, and then I just asking myself, why is it happening this way while it's not supposed to be though? So you have to be careful with the details and pay attention on many little factors, and then you can see that actually science is quite random and it's probably like a cooking process. Yeah, most of the times you don't have the particular recipe, and to do the valuable research is first of all to bring new ideas and to get inspiration somewhere else, probably.